everyone, and welcome to Thermal Control Magazine's live interactive session on VRF technologies for energy efficient air conditioning. The Indian air conditioning market is estimated to be around 7 to 7.5 million units per annum, with rupees 15,000 crores, of which around 6% belongs to the VRF segment. While the VRF market contributes to 9% of the global market, and it is poised to create a valuation of $29,478.1 million by 2026, registering a CAGR of 11% by 2026. VRF systems are known for the superior energy efficiency and its ability to offer a quick ROI in many applications. Increasing urbanization and industrialization, alongside the advances in VRF systems and HVAC technologies, fuel the growth of the market. Similarly, increasing construction activities and the development of energy efficient technologies and products drive the growth of the market. Today, on this note, we are going to be a part of a live, interactive and engaging session on VRF technologies for energy efficient air conditioning, where our industry's leading experts will talk about the significance of energy efficient air conditioning and the demand for VRF and VRV technologies. Also, we will discuss the price competencies after the air conditioning parts have become more costlier than before. Ladies and gentlemen, it's an honor and privilege for me to introduce you to our today's distinguished panelists, Mr. Vikram Murthy, Director of Univec Environment Systems and past National President of ASHRAE and past President of Mumbai Chapter ASHRAE. Mr. Deepu Manuel, Product Global Head for VRF Living Environment Division at Mitsubishi Electric, and Mr. Abhinav Gupta, CEO and co-founder of Active Buildings. So delegates, get ready for an interactive and engaging session on today's topic of VRF technologies for energy efficient air conditioning.
What are the considerations you need to keep it in mind while designing VRF facility in terms of maintenance?
So, over the years, from my own personal experience, that is one of the most important aspects of designing a VRF system. That is, you must lend it to being able to be maintained. If you put the outdoor units in places where you cannot approach it, if you put the indoor ducted air conditioners where there is no place to go behind it to take out the filter, then maintenance will be a big problem, right? So the more time you spend designing the system installation, the better will be the maintenance. And for that, you have to spend a lot of time and discussion with the architect, who is not likely to give you all the luxury of the space which you require, because he needs to put in so many more things. So my simple answer is, to design a VRF system well, you must also be able to plan where to put each machine, because the VRF system has its own very good maintenance indicators. It is own, shall we say, troubleshooting methods are there. It gives out data about what is wrong with the unit. So the VRF system is very well engineered. It takes care of lots of things by itself. But the most important thing is keeping it clean and not having leaks. I think if you can ensure both of these in the design and lay out your piping well, see that the supports are very well done and there's no vibration, and be able to access everything, and of course do your regular routine maintenance work, then the VRF system will last for a very long time. We have a residential system in Mumbai which is 15 years old, and it is for a big customer, a big company. So they are very particular about routine maintenance, even if that place is not being used. And so it is working fine, right? Condensing unit, biggest problem. Dust is a big problem for the outdoor unit. It will go into high condensing. So this is my short answer. Maintain cleanliness, maintain spaces, provide spaces, the VRF system will work fine. Client should be aware that maintenance is a very important part of his spending money every year. See, the stack effect is a very complicated thing. The stack means, does the hot air rise and affect the unit above it? So if you want to avoid it, try to space them laterally so that the hot air of one doesn't go into the intake of the other. So 3 meters, 4 meters is a good distance to keep apart, but you must have lateral shifting. You must ensure that in a tall building, all the units are not in the same line. So that will cause the stack effect. The machine right on the top will be getting the hottest air, right, of all the hot air from down. So it is possible to avoid stack effect by good design. But there is one problem. Many VRF systems are in buildings where only one shaft is given for all the outdoor units. That is likely to have a big stack effect problem unless you plan to extract the air in some way. So those are detailed aspects of design. Often stack effect avoiding is best done with the help of the architect.
How do you see the research and development or advancement in VRF technology?
Yeah, I like to refer to Vikram sir's presentation also. He was mentioning that today VRF has been accepted in almost all kind of applications. In addition to this, in the last 2 decades, maybe uh, maximum adoption of various different developments in other fields in electronics or in terms of sensors and R&D in the VRF field itself were more compared to any other systems available. I mean, that is the reality. So combining all these aspects, we can say that an initial momentum is already gained and we have reached to a level where we can see more companies will be entering into the segment with more investment into R&D, and we can see maybe much faster technological development in the VRF system because of the large adoption by the customers. So finally, when market accepts, people invest and new technologies comes, competitions will come. So all these will finally benefit the customers and also will benefit the VRF as a segment. Whereas like VRF is most of the parts of the VRF systems are factory assembled in a controlled environment where you have only the piping between indoor and outdoor, what is a condensing unit and evaporator is mostly field driven. So we have a completely assembled system which can work as per the design itself with the minimum variations. So when you have a controlled systems which is available, you can predefine and you can add a lot of sensors and feedback loop into the systems, which will work perfectly as per the plan. Like if you add a external sensor, like you procure a sensor from a market for X brand and add, and then you try to link it with the feedback system and then your system to adjust to that, then the quality feedback, so many things of that sensor may be varying not exactly as per the plan. So when you have a completely controlled and environment manufactured systems like VRF, or you can say mostly, adoption of new sensors and new technologies and other things are much faster because the results what we plan at the R&D stage or what we expect at the factory stage will be available at the customer site. So customer also will be happy that he is getting the result which has been told to him before he is taking the decision. So this is one of the reasons the adoption of various technologies is happening faster in the VRF systems.
So typically, what we do and basically what our technology is one of the connected sensors, as Mr. Deepu mentioned. What we've developed is a sensor that monitors complete indoor air quality and is able to integrate with VRV or VAV type systems and provide them live feedback on CO2 levels, PM10, PM2.5, TVOCs, temperature, and humidity. So when choosing for a filter, we not only look at the PM 2.5 and PM 10 levels at a particular point in time. Rather, we look at it from a behavioral perspective from for a particular week. So from Monday to Sunday, including all the occupant days, as well as the 2 days where there are no occupants, we like to see the complete patterns. So what happens to the CO2 levels? Do they rise up significantly? Do they stabilize? Is the fresh air levels enough? And at what point is outdoor pollutant introduced? What is the behavior of the space after the air condition systems has been switched off? So based on all of these things, we recommend to them that a particular type of MER filter. So there is not just trying to recommend them what grade of filters is required, but also help them source some of these filters, because it's very difficult to find the right kind of filters that match the performance that the rating desires. I mean, I can say that, you know, you need an F8 or an F9 graded filter, but if it is not performing to that level, then, you know, it absolutely doesn't make any difference to the indoor air. So we recommend based on the MERV standards, and, you know, we're trying to find the other equivalent of the MERV 18 or a MERV 13 equivalent of that to F8 or F9, and those grade of filters usually we recommend. But for doing that, we do at least a 3-day study to a 7-day study of their indoor air quality and map it completely.
What are the types of insulation materials recommended, and what are the design thickness of these materials for best energy efficiency?
The whole important matter is that your insulation has to protect as well as prevent thermal gain or loss, and also prevent, most importantly, moisture gain or loss. So therefore, one of the most important things is it should be very tight. It should not allow air to leak inside, because once air gets in, then moisture will start, corrosion will start, and all sorts of other things will happen. The other matter is about thermal rise, because the pipe lengths are long, and so if your insulation is not good and air is trapped inside, and then there's going to be large amount of thermal losses. So we get very good EPDM of very correct diameter pipes available, insulation pipes, and you should select those, and they should tightly fit around your pipe. And wherever the joints are there, you must join them carefully with the prescribed tape, which has good adhesive. So I would recommend 19 mm, although you might do 12 mm. But if you can do 19 mm, it's very good for the piping. And similarly, for duct insulation also, everything should be tight. And in the duct insulation, it depends on the return air conditions of temperature and humidity. So if you have high humidity, like in Bombay, go for thicker insulation. So anywhere from 12 to 19 mm is good. So insulation is one of the great ways of saving energy. So there is a whole separate discussion on that. I will recommend Atul by an email, which I can recommend to him, to read one book all about insulation, which ISHRAE has released recently. It's available. It's a very cheap book. You can buy it online. So all about insulation, you buy that book, written by one Mr. Ramesh Paranjpai. Beautiful book, very well illustrated, everything it will tell you. And you read that book, you will get all your answers very nicely.
Only request like let us not use thumb rules like Vikram sir also like 12 mm 19 mm. There is a specific reason for sending that thing. He's not recommending thumb rule. Let us look into actual conditions and use that. That's the only thing.
Does chiller give a better reliability than VRV?
So the whole thing about VRF is that you can scale it up, and you can scale it up to 3,000 tons, 4,000 tons. You can do very big VRF systems. But at the end of the day, what is going to be your biggest problem? It is going to be attending large number of outdoor units for maintenance, right? That is going to be your biggest problem. So if you have end user. For example, I'm giving you one name. It doesn't mean that this is a name which is chosen by me. Suppose you talk about Reliance, very large, or you talk about, let us say, TCS. These guys have very large facilities, commercial facilities and all. And they choose sometimes chiller, they sometimes choose VRF. It all depends on an application type of way of doing things. So here is the point. If you have a system operator, like a person who's renting out facilities and commercial spaces, he would prefer to have a chiller system because of his energy efficiency in managing it, because chillers certainly have a very high energy efficiency, and the distributed effects of chillers with water is certainly very good. And so it depends on who is using the system and who is delivering the cooling. So central plants are preferred by large facilities like malls or hospitals or hotel or large commercial buildings which are operated by somebody. And so then the chiller offers the central way of managing things, right? And the AHU or the air handling unit on the floor is much easier to manage than managing many indoor units. So it's application, and who is going to operate will decide the choice of system.
I mean, the first thing to look into is humidity. Always, one of the most important things to see is what are the humidity patterns outdoors, and therefore what are the humidity patterns indoors, and basis that is definitely one thing. The other is also to look at outdoor and indoor air quality on a whole. So even if you might be in a city, like for example, and we've done some work over there, but you can be in a city like Baroda, which generally has a very good outdoor air quality, but you might be in a situation where there is nearby activity causing bad outdoor air quality, which is getting introduced into your system, which is getting introduced in your building by some ways or means, some leakages. There are n number of reasons why that can happen. But understanding the indoor air quality and the indoor PM 2.5 levels is again very important. So humidity and PM 2.5 would be my short answer to that question.
Do you see a slowdown in adoption of VRF systems in commercial buildings? What will be the demand trend in residential building sector?
Yeah, see, COVID when I say commercial buildings, maybe large shopping malls and other thing, there is a decrease in new developments. But when it comes to office applications where people are working there, we are seeing more compartmentalized offices or more individual cabins. So we expecting that there will be more adoption of VRF systems in office applications or similar kind of applications. Maybe a few, including maybe restaurants and other thing. Having instead of having a big hall, it will be more compartmentalized cabins to prevent air mixing between that. So that we can see more adoption. Residential segment, since the height of the buildings are getting increased in India, VRF adoptions are actually getting more in that point of view for apartmental or condominiums. When it comes to individual buildings, individual residences, there also now aesthetic is coming into a place, since VRF can have a one outdoor which can be far away, which is not visible. So there is a more adoption of individual residences and standalone residences like villas. We are seeing VRF system not from efficiency point of view, more from an aesthetic point of view, because the availability of various type of indoor units to suit to the interior conditions, and the service point of view moving into one single location. So except for commercial like shopping malls kind of application, public spaces we can say, rest of the spaces, then slowly there is a increase in adoption of VRF because of more compartmentalization is happening. That is what we feel it is going to happen post-pandemic situation also.
Can we use water spray on outdoor coils to elevate the condensing process in order to increase the efficiency of the system?
Certainly, this has been tried. So the problem is the following. The problem is not that it's a bad idea. The problem is managing it in terms of the okay, let's use a strong word. The mess you will create by spraying water on those coils. Suppose the outdoor unit is outside and you are spraying water, it will fall on some fellow's head below him, or it will fall into some other building. So it is a good idea to spray if you have a very large terrace. The other problem is, which is another big problem, is the quality of water. If the water has salts in it, you cannot see the salts, but after some time they will settle on the aluminium fins, and all the fins will be eaten up very quickly. So your plan of bringing down the condensing temperature will result in failure of the fins. So a better way, another way, is to have wet pads surrounding the condensing unit, such as the unit which I showed you on the terrace, where there is enough space to put wet pads around and manage the water dripping into some tray which will hold that water, and that water has to be recirculated back and back over that thing, and some fresh water, because it water will evaporate, so you must have a good supply of water. In the end, the better solution is to go to Mr. Deepu Manual and tell him, I want water cooled VRF units. No, I'm just saying it in a funny way, but that is the right answer, because this is a good, I must not criticize his question. It's a very good question, and it will certainly bring down the temperature. So there is one Mr. Surendra Shah in Bombay. He's quite a senior gentleman. He has tried this for VRF units, where there is space, putting these pads and wetting them. But it has to be managed well. After some time, those pads will become bad. You know, they will develop fungus, and some other problem will develop over there. So managing it is important. You must have a good team of people to manage that spraying system.
The mess created by this water in the air cooled system is much more difficult to manage than the efficiency which we are trying to achieve it. So that is the answer from an OEM. When people ask us whether will you allow it, we say no. The reason is that
India has seen from 2016 uh, organizations like ISHRE have done a fantastic job in creating strict air quality standards, not just air quality standards, but also environment quality standards like acoustics and light and whatnot. And when it comes to following those, I think ISHRE as a chapter has inculcated a lot of engineers into their entire air quality testing and air quality improvement program. And we've seen that typically people who have been in ISHRE or have looked into the ISHRE standards have a much better idea of what is the ideal air quality required. So those are the people where we see adoption. Adoption is also seen in green buildings. Any building that is going for an IGBC lead or a USGBC lead certification will look into factors like CO2 and PM 2.5 much more closely. However, you have standards like ISHRE that not just define PM 2.5 or CO2 levels, but they also talk about what is the humidity that is required as per your ambient conditions. If you are in Delhi, if you are in Pune, then your ambient conditions dictate your humidity should not go above this. If you're in Mumbai, if you're in Chennai, then it is different. It is the standard takes into account for the geography that we live in and the vast geography that we inhabit, right? So ISHRE standard definitely I think is one good air quality norm that is being adopted in conjunction with certain international standards like reset, well, and as I mentioned earlier, USGBC lead provides certain norms. And a lot of government activity has helped in adoption of green building and therefore adoption of stricter indoor air quality norms. Before I enter into the virus related discussion, which I think before the conversation, Deepu and I were talking a little bit about it. So I'll come to that in a little bit. But you also asked an interesting question that do we have IAQ adoption more in North India due to bad air quality index there? I have to tell you something that bad air quality is not limited to North India, though the media is a lot more focused on North India and North India's bad air quality. We have similar bad air quality issues in Mumbai, in Bangalore, in Chennai, in a lot of different parts of India where there is rapid industrialization, there is agricultural activity, there is human as well as vehicular traffic contributing to the bad air quality. Although having said all of that, the media focus in North India has made people in that region far more sensitive to air quality issues. However, after the pandemic and after recent developments by leading organizations where they have claimed that this is an airborne disease, we have seen a lot more adoption by end users on regards to filters and on regards to fresh air. Like they are asking questions. They are not looking at the advertisements as Deepu mentioned in our earlier conversation. It's very absolutely correct, wherein people are looking much beyond and what is being advertised in front of you as a solution that this is going to 100% kill the virus. No, people are now looking into the norms and the guidelines suggested by ISHRE and by LEED for so long that you have to maintain a certain amount of fresh air, you have to maintain a certain amount of filtration, you have to make sure that your air is not too dry or not too humid. All of these things contribute to good air quality, and it also helps in reducing the risk of a virus spread. So I have to make it very clear, maintaining these things does not mean that you're going to kill any and every presence of the virus in the indoor air, but it does restrict the movement of the virus to either a very limited location or to a very limited set of people, right? So maintaining a good amount of fresh air, maintaining a low amount of PM 2.5, low amount of aerosols, maintaining a good amount of humidity will make sure that the spread of the virus through the air is restricted, but it can never be completely eliminated. You can have, anytime a person can enter the room with the virus, and therefore now they have introduced the virus in the air. But taking care of these norms in the way Ishre and Lead have defined, you can definitely reduce the risk by a significant margin. And a lot of studies have also complemented that fact.
Very good. So the government of India's Ministry of Environment released that India Cooling Action Plan in March of 2019. It is a seminal document, one of the only countries in the world which has such a document. So the good thing about it is it is prescribed over the next 30 years how we have to bring down the consumption of energy and increase the energy efficiency in different types of systems. So, in the terms of equipment, they have defined all types of equipment: VRF, chillers, unitary equipment. They have also defined other things like evaporative cooling, radiant cooling. So, everything is well described there. And the norms of energy efficiency are well stated over there. And so the India Cooling Action Plan has got lots of people who are promoting it in terms of companies themselves are bringing down, along with the Bureau of Energy Efficiency, which has ratings for energy efficiency. So the India Cooling Action Plan, number one, will reduce efficiencies, or rather will increase efficiencies very significantly, will also bring down global warming. That is the phasing out of refrigerants, the bringing down of leakage of refrigerants. And another big factor which they have said is the importance, which you have also been talking, all of us have been talking about maintenance. So good maintenance also contributes to energy efficiency, because Mr. Deepu Manual will give you a very efficient VRF system, and you will not maintain it properly. It will be the worst system in 2 years' time. Or it can be as good as new, and it will contribute to better energy efficiency. And so the India Cooling Action Plan is a very nice document to read by all young people here, because it gives a good pathway to the next 30 years how you can see India will be performing, because we have to bring down our energy efficiency because we are growing our air conditioning. So it is very important, correct? So the plan is put in place for that.
So thank you all the panelists and thank you Mr. Nair and Mr. Meghna here. It was a very wonderful session, and it was really an important session considering the pandemic situation and VRF as a technology which is getting more and more adoption into the main designing and acceptance from the customer's point of view. So these kind of webinars are actually helping people to open their eyes to see the latest developments and technologies which are happening in the field of air conditioning, and specifically into the VRF in this segment. So my expectation is like Mr. Prasad will keep on coming with webinars which will be exciting to the general public and also to the people who are connected into this industry. And also people who are using the air conditioning. I think most of the people will be somewhere or other way will be using air conditioning for their personal comfort, not necessary to be into the development or designing or installation. So these kind of webinars will be an eye-opener for most of the people. From a limited knowledge, they are going to get a wide variety and a lot of knowledge and lot of future-looking development which is going to come and give confidence to the people to adopt the new technologies, or not only in VRF, in the air conditioning field. So thank you very much for this program, and happy to be part of such programs in future also.
So I think to extend to what Deepu is saying, and to what Mr. Vikram also mentioned earlier, I think webinars like these not only are introducing people to new technologies, but giving a lot of power to our future designers and the future working professionals in the industry on what are the best strategies that they can implement. So I think discussions like these not only help them, but it also helps me understand that why I would not look into something like a water pad, or if I have to consider a water pad, what are the things outside an outdoor unit, as Mr. Vikram mentioned, what are the things that I need to take care of, and if and things like this do stick at the back of your head and do help you in incalculable ways when you're actually faced with a condition like this. And maybe a solution like this is the right way to go, or maybe not. I mean, like, both those things are very important, but to understand what strategies are being implemented outside than what is visible based on real world conditions, that is always a very eye-opening experience, and I frankly found it very interesting.
There will never be the last word, because you have organized a very good program, and so the life must continue. And I must compliment you for TCBU Thermal Control Business Update. So the word update is also emphasized by Abhinav and also by Deepu. Updates are what are happening. You represent them well in your magazine. I will encourage all people who participated here to have some interaction with your periodical. But my biggest not takeaway, my biggest recommendation about this wonderful topic of VRF is that it gives you a very wonderful opportunity to learn design, because it is so flexible. And you will also, because you are an installer, you will also be able to see for its life how it's behaving in all its little parts. Get involved with your technicians about seeing the performance of the VRF. This will only make you a better designer for the future, and give feedback to the company whose products you are selling about improvements. Listen to your customer. VRF says listen to your customer. He is always right, and you will find the solution for him. So VRF offers this flexibility, because there are so many units and there are so many combinations. But the biggest thing is that you get good information. The system provides you good information. So I think that's a good thing which we have learned today.
We hope you have enjoyed this session thoroughly. Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Vikram Murthy, Mr. Deepu Manuel, and Mr. Abhinav Gupta for being a part of us. I would also like to thank our editor, Mr. Prasad Nayak, for taking this initiative. With this, we announce the closing of our today's session. I request you all to stay tuned with us for more such sessions. Until then, thank you, goodbye, take care, and be safe.